Okay. Hello everyone. Good morning, good afternoon, or maybe even good evening if you're in my part of the world. My name is Tom. You may or may not know me as TomNomNom, and I work at Bishop Fox. I think my title might need updating. I think I'm a senior security engineer now. I do engineering and that kind of thing, building software and tooling and so on and so forth. And I've done a bunch of open source work as well. And I just remembered also I have a slide for this as well of who I am. So hello, I'm Tom Nom Nom, and I love tools. I'm not ashamed to say, and I also make tools, and those two things are entirely related. So. I think a pretty good place to start when talking about tools is to ask, well, what even are tools? And I think they're anything really that augments your capabilities, whether that's physical capabilities. In the case of, I'll try and talk a little bit louder. I'll try and project my voice for you as best as I can. Um, Things that augment your capabilities, well, physical tools, mechanical tools, but also things that augment your mental capabilities, things like software tools, but it doesn't matter what kind of things they are. I love them all. Also, crows use tools, and crows are cool. So I titled this talk something like the why, how, what, and so on. And it's all a little bit blurry, really, but I want to do my best to try and break down at least some of it. And start with why make tools, right? And one reason that's deeply personal to me is that making tools is really a display of affection for tools themselves. If you love something, then learning to make them and understand them is a really great thing to do. But also, and this might sound um, like an exaggeration, but you get to pick your superpowers when compared to an unequipped human um, who doesn't have tools. Someone who does have tools basically has superpowers, really. You know, the ability to lift more weight or move more stuff or do more things at a superhuman level. Also, you know, I think making things is fun and rewarding, um, which is certainly a deeply personal reason for me, and I hope for other people as well. But also, from a more practical perspective, sometimes you need a special wheel. So you will hear the expression, "Oh, don't reinvent the wheel all the time." But if you look in the industries that use a lot of wheels, you'll find that they design new wheels all the time. Very highly specialized wheels for different kinds of vehicles with different load capabilities or different speed capabilities. Very rare, actually, that an off the shelf wheel is a good fit. But also, you know, having your own tools means you can improve them as you learn more. And I think that's a really important thing, because if you use other people's things, sometimes it can be difficult in the case of open source, and sometimes impossible in the case of closed source things, to modify those tools as you become more experienced and know more about what it is that you want. So when make tools, which is just about grammatically correct, I think, probably one of the most obvious times is when nothing exists for what you need. I think that's probably covers a lot of the cases that there are. Exactly, when no tools make tools. But also, you know, might be a little bit more subtle than that. So it might be you've tried to do something sort of the simple way or with a tool that purports to do what you want, and then you find out that actually things are not quite what they seem. Things are being it's a bit too difficult. There are also occasions when you need to know exactly what is happening, and that's I think the case in security more often than in other fields, right? Very often we find ourselves dealing with systems where the difference between one bit being set or not is the difference between a vulnerability being found and not. And that kind of hyper specific control over what you're doing is sometimes absolutely necessary. But another thing I want to really try and demonstrate today, if I can, hopefully, is just, and it won't take very long. There's this XKCD comic from Randall Munroe. Um, Great comic. I love it, but I think people maybe sometimes take it a little bit too seriously. It gets banded about almost as an example of why you shouldn't automate things, or in my case, like why shouldn't I write a tool? And it's sort of, oh, well, the automation really takes over and it becomes a Sisyphean task that's never completed. And that doesn't have to be true, but I think that stops some people from even starting, which is sad. So if you decided that you should make a tool, you may be wondering, well, how should I make a tool? How make tools? And we're talking about software tools here, of course. And one of the things I want to really get across to you is that the best language is the one that you know the best. If you are an expert in Java, then probably Java is the thing that you should use. Having said that, I don't think they're all made entirely equal. But for example, Bash is fine. Some people will tell you, oh, not a real programmer if all you're doing is shell scripting, and that's complete baloney. If you ask me, it doesn't really matter what the language is, and also things like Python is okay. People use Python. Node.js exists. Personally, I think Go is quite nice, and I'm going to be doing some demos in Go. But I think it has some advantages when it comes to distribution and that kind of thing. But for the most part, the languages are mostly equivalent. But I will say, I think Rust is maybe a little bit too difficult for me personally. My programming background is in memory managed languages, and I've never had to deal with managing memory. So having syntactic hoops to jump through, as it were, is not something that I found very natural. So the tool making process then, and this is what it really boils down to me, is that you have a problem. I've talked to a lot of people in the past who will say, oh, well, what tool should I write? And I think that's the wrong place to start. For me, it always starts with, I have a problem that I'm trying to solve, and either I can't do it with the tools that I have already, or I can't do it in the right way. So I can't do it fast enough, I can't do it with enough accountability, or there's some other thing, some other barrier. That's the kind of problem that I'm up against. And then try and find the most simple solution that you can. It's very, very tempting to go off and design the world's best tool to solve all of the world's problems. But the problem is that you will not finish. So look for the most simple solution that there is, or the most pragmatic maybe. And then maybe sometime later you'll have the same problem again, and then you can go back and you can improve the previous solution, and maybe there'll be a few iterations of that. And something I think is important for the way I think about tools is that when you have a new problem, build a new tool. That goes back to the building the most simple solution. There's this quote from a guy who's much smarter than me called Thomas Limoncelli. I'm not 100% sure. I really should have double checked on the pronunciation before I tried to talk to people about it. But it's this idea of not building Iron Man type tools. It's building, not building Ultron-like tools, building Iron Man-like tools. And I won't read the whole quote, but the general idea is you want to try and build things that augment you as a human, not replace you. for a whole bunch of reasons related to observability and accountability, but also creativity and so on and so forth. If you can um, make it so that you can do things, but you remain in the driver's seat, you will generally, I think, do better and have a more satisfying life than if you try and replace yourself. And again, I think that's a task that is probably never ending. So in contrast to that is sort of the Unix way of doing things, which is the way I think about tools. And this guy, I don't think he used Unix. He predates it a little bit, but still a great quote, which is, perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. This iterative, sometimes radical simplification of the thing you came up with the first time is sometimes the best part in building tools. So more concretely, that Unix way of doing things is to make them mostly communicate using standard out and standard error and standard in, which are the standard Unix interfaces to every process. And this enables something that I think is really genuinely beautiful, which is that two things written by two people who never met, maybe in space and possibly also in time, they may have lived at different times, can write tools that work well together and be greater than the sum of their parts. And I genuinely really think that that's a beautiful thing. And that's a good way to also write your own things. Even if you're writing both halves of the equation, you can be surprised in the future how well two things can work together, or you didn't think of them at the time. Having said that, some other great Unix people have said plain text is the standard interface. The reality is that sometimes we must also deal with structured data. I think the nice sort of happy medium is to use JSON lines as tool output, just as a sort of an aside. Some people maybe are not quite as pragmatic as I am, or perhaps as they should be. I also want to say I'm a real advocate for when you encounter a problem, have a real good hard think about it first before you go searching to find other people's solutions to the problem. For most problems you encounter, or let's say for many problems you encounter, someone else will have the solution. But it's very, very difficult if you look at that solution to get it out of your head and think clearly about the idea without its influence bearing down on you. So have a good think and come up with your own solution first. And a lot of the time it won't be as good as what's out there, but sometimes it will be better. And perhaps you wouldn't have come up with it had you not taken the time to think about it first. I also want to advocate for building things that you need right now. You sort of touched on a bit with the tool making process, build the most simple thing. I really, really mean it. You might think that you're going to need stuff in the future, and most of the time you will be wrong. And even when you are right, it would have been easy to do it in the future anyway. So Yagni is you ain't going to need it. Build what you need now, and don't let other things distract you. I also want to advocate for sharing tools that you have built. I think a really great way to do this that I kind of stumbled upon by accident is to have what I call a hacks repo. You could call it a projects repo or something along those lines. But the point is to lower the barrier for sharing things. And even if, so you just sharing the code for your own reference so you can look at it later more easily, have it shared. So it's a backup of stuff that's on your laptop. Even if no one ever looks at it, I think it's still worthwhile. And I think some of the absolute best things I've made were throwaway contributions to this repository that somebody else found useful and then eventually got their own repository and turned into a tool of their own. So that being said, Anton has said that repo's been so useful. See, I'm so pleased. Whereas, you know, from my perspective, it's literally just uh, I wrote this code to do one thing once, and not sure I'll ever use it again. But there it is. You know, it's not getting a README or anything like that. So, getting a bit more concrete, then I said I'm going to write some demos in Go. And I want to give a preview of every Go tool that I've written just about using this standard in, standard out way of writing things. And this is the framework for it. And we'll look more about it as we write it. But I think, yeah, that's the crossed fingers emoji where I'm going to have to actually try and type in front of a couple of dozen people and hopefully not make too many mistakes. Let's get this out of the way because we're probably going to need the Go documentation at some point. I'm not ashamed to say I can't remember everything. So what I have planned is, because it's a nice and simple, hopefully, thing to do, is a couple of tools. And the first one is going to be for helping to detect cross-site scripting, which I know is not a very interesting vulnerability, but it's a very well understood vulnerability, and therefore I think it makes for a good example. But you can mentally swap it out for anything else you want. So the tool I want to build is one which takes a URL, and I think I actually have prepared somewhere reflector, yeah, an example for this. So I've got a URL like this that has a query string, and I want to know, is this part reflected in the page, right? And in reality, for cross-site scripting, you need to know, is it reflected, you know, when it's got special characters and all that sort of thing. But that's always the first stage for a reflected cross-site scripting vulnerability, is that the data is reflected. So let's give this a go. So I'm going to make a directory, and I'm going to call it reflector. You can see the tmp-reflector directory already, where I had a bit of a dry run at this, but there you go. I'm going to copy my input file into it. Why not? Reflector. Reflector. There we go. And I'm going to get myself a little split there. I'm going to make a main.go. And I'm going to write the first part of that. So I've got my template sort of in there, the main function. There's not very much. And we said before, there's that outline of every, wow, Copilot is very keen, isn't it? So we mostly ignore what Copilot has to say today because that's not very useful. But the thing we're going to make is called a scanner. So we're going to use from the buff.io package a new scanner which operates over OS standard in. Here we go. And then we're going to loop over that. So we'll say for sc.scan. Again, we're mostly ignore Copilot. We're going to add a line of text. And then we're just going to print it. One of the things I try and do when writing code is to run it as often as possible. We want to take in the input. So at the moment, this code effectively does nothing, right? It reads, it's like the cat program. So it reads lines of input and then it prints them. It doesn't do anything with them. And that's fine, but just being in the habit of running the program regularly and seeing what it's doing, I think is actually really important. Now, so we want to do some things. We want to make a request to this thing that's a URL, and we want to see if any of the parameters have been reflected in its input. So let's do that. So I guess the first thing we'll start with is making a request. So we'll have a response to a request and an error. We're going to use http.get on the raw URL. If there's an error, we're not going to handle our errors very gracefully today, I'm afraid. We're just going to log .fatal on the error. Oh, I can't bring myself to do that. Sorry, we're going to fprintf to standard error fetching URL. Yeah, Copilot is okay at that, it seems. And then we're going to get some response out. And we want to see if the query string parameters in that URL exist in the response. So we're going to need to read the body. Yeah, we'll read the body, that's fine. We'll close the body afterwards. And to do that, we will use, yeah, IO read all. If there's an error, we'll do that, that's fine. And then we'll close the body. We should, yes, always close the body after we've read it. And then for now, let's just print the body and make sure it's working. We said that we would try and run this as often as possible. And the output's not going to be very useful particularly, but we can see there's some HTML and so on scrolling past. So that's useful. Now, what we want to do is take our line of input and let's put that there for now. And parse the query string part of it out, and then look for this value and see if that exists in the body response that we got back. Should be, hopefully, a fairly simple thing to do. So the first thing we need to do is parse the URL. So let's say we will use url.parse probably on the line, and if there's an error, we'll rely on Copilot to fill out our error handling code for us. Very handy, very useful, very kind of it. So this URL that we've got back has a, is it called the query part of it? Yes, which returns url.values. So the query is going to be that. Returns this URL values. So we'll want to loop over that. So we'll say for key values in the range of Q. And we don't actually need the key. Now values is a slice, so we will say for value in the range of values, and we want to say, does this exist in the body? So we'll say if strings contains value flag, that's not what we want at all. A string version of the body contains that value, then we will print the URL. Let's see what we did wrong. Braces aren't matched up properly. That one's fine, that one's fine, that one's fine. We have lost the one off the end of our for loop. Okay, let's run that. Now, iterating on our tool, we have something that is, we think, doing what we want, mostly. The problem is that we have false positives, I think, so we need to do something with that. So if we go and follow this link, for example, which has very helpfully opened in a browser that's not on the screen that I'm sharing. We'll find if we go to example.com, it does indeed include the word example. It's right there. The problem with that is that, of course it does. So instead, I think what we need to do is rearrange our code a little bit and make the values that we're giving a little bit more unique. So how about instead, we'll parse our URL right up here at the beginning, and then we'll make a new query. So we will say our query is going to be a URL.values. Makes sense. And then we'll say for key and we don't care about the value in the range of uQuery, we will add the key and we will put in something like a new UID instead. So instead of the value that we had there, which was hello or example, we're going to put in a UUID, which is theoretically at least very, very unlikely to appear in the URL. So, and then we need to set the raw query on the encode, and this becomes u.string, and this becomes u.string as well. So we have the string value of it. So don't actually have a Go module, so let's just fix that. Go run. Cannot use uQuery URL values as assignment. So what have we done wrong? So we've got no, oh, I don't want to do that. Of range u.query again. There we go. Cool. So now we have our false positives gone, right? So previously we were flagging to say, well, example.com has this reflection in it, and it didn't in reality. But by throwing those out for UIDs, we've sort of fixed that problem. And, you know, cross-site scripting and reflection and so on and so forth is a pretty well understood problem. So probably the next step here would be to say, okay, well, for all of those reflected values, I want to understand the context in which they're reflected. Is it in an attribute? Is it between tags? And also what special characters can I get in there, and so on and so forth. But because this is mostly a demonstration of a tool, rather than something that's you know, doesn't already exist and so on and so forth, I think we'll leave it there and say this is already useful by itself, and start to look at the next bit. So we have a question from the live stream. Is Go your preferred language, or chosen for performance and library reasons? Ooh, Go is definitely my preferred language, certainly for tools, and tooling, command line tools especially. And the reasons are many, one of which is very difficult to describe, in that when I started learning the language, it just kind of clicked with me and made sense. You know, I had previously worked in PHP a lot and was sort of familiar with C-style syntax and so on. I do really appreciate that the language generally mostly has sort of one way of doing things. So, for example, it has only for loops. Whereas, you know, if you're writing in, say, JavaScript, you can say, well, this could be a for loop, or it could be a for in loop, or it can be a while, or it can be a the for each method, or maybe this is actually a map operation and so on. You spend a lot of time thinking about exactly how you're going to do things rather than what it is you want to achieve. I do also appreciate the performance of it. And also I really appreciate the standard library of it as well. I think there's a lot of languages I've dealt with. So Node.js springs to mind. I've written a lot of things in Node.js over the years, and very few projects have fewer than, say, 5 external dependencies. And whereas I would say most of the Go projects that I write have 0 or 1, maybe 2 external dependencies for the most part. And there's a real tendency to think, well, an external dependency is work saved. And it may well be, depending on what it is and how well it's maintained and so on. But it may also be that it changes and causes you problems in the future. Or maybe it has behavior that you do not expect. The Go standard library is pretty comprehensive, and for the most part does the vast majority of things that I want when I'm tackling these kinds of problems to do with text processing and making network requests and so on and so forth. So we did get the UUID package. I think it's probably the Google one imported in this case. It'd be nice if Go had UUIDs built in. It seems like a pretty an obvious thing, but it's a really great question, and it's one that I could spend a very, very long time talking about, and maybe another time. So we have this this tool. It's doing something useful. At least I hope it's doing something useful. But I want to deal with a situation that I think comes up a lot in particularly sort of that bug bounty style of hacking, where you're targeting lots of different hosts all at once, or maybe your engagement is a company that just has a lot of stuff. You find yourself with a situation where I have a whole lot of URLs and I want to do some kind of scanning on them, and they have inputs which you may or may not know about. And obviously there are a great many tools out there to do things like fuzz for different parameters and so on and so forth. Often, usually sort of on an individual URL, but I want to do a slightly different take on it. And that take is that it's possible, probable even, that you may have a record of a path. Maybe it came from sort of the archive.org. There's a tool called Get All URLs that fetches URLs from there. Very useful tool. And it doesn't have the parameter that it's vulnerable. But another URL that you have on a different path that isn't vulnerable does have the parameter. And it's a situation I'm sure that we've all come across. So we can see down here, by removing that search query string parameter, we're not spotting that reflection anymore. So let's solve that, but let's solve it with a different tool entirely. So I'm going to make a tool called allparams, and yeah, okay, sure. And it's going to be another Go tool, and I want a copy of that input file in here. Whoa, that is not what I wanted to do. Oh, what have I got now? A file called commodot. That is definitely not what I want. So we're going to have another Go tool, and hopefully this won't be a surprise, but it's going to start off in exactly the same way. We're going to make a new FIO scanner over OS stdin, and then we're going to say for sc.scan we're going to get a line of text, sc.text, and we're going to print it out to make sure it's working. Go run main.go. Oh, don't forget to attach the input. So we're in the same place as we were. So, you know, I really wasn't kidding when I said most of the tools I write start this way. And you would think maybe I would have this as a starting template instead of just the empty main function for that reason. But part of me actually really almost enjoys the typing out of it each time. You see, sometimes even occasionally, like Copilot will suggest something and I'll type it anyway. Typing is sometimes the thing that gives you time to think about what it is you're about to do. So what we want to do is parse each one of these things as a URL, which we'll do. So we'll parse the line, and then if there's an error, we'll print println. See, Copilot's not always as smart as you would like. So we're going to parse each URL. If there's an error, we're going to do something. and we're going to look at the query values. And our goal is to take every URL and then store the query string parameters that we've observed against the hostname for that domain. So you can see we've got 4 different host names in here. We've got example.com, httpbin.org, example.net, and poc.lol and poc.lol, which is one of mine, and possibly my favorite domain that I ever bought for doing proof of concept code for vulnerabilities and so on and so forth. And we want to track all of those, and then we're going to output the list of URLs again, but this time with every observed query string parameter against it. So let's get going. So we want a place to store the query string parameters that we have seen. So that is going to be something like params is going to be a map of strings, which is going to be the host name, versus a, do we have a list of strings? We could have a list of strings. Maybe we want a map of strings. We'll do a list of strings for now. Why not? So we've parsed the URL, and then we're going to get the host name, and we'll want to store that. So we'll say if, nearly right, Copilot, we haven't seen the host name yet, then we're going to make a slice of string there, size 0, in case we've seen it. And then we are going to say for all of the keys in the query string parameters, we're going to store those. Does that look right? That looks right. Now, a lot of the time that I write tools like this, I'm really aiming to have a tool that streams data, so that you get one line in, one line out. But this is a case where that's not really possible. So we need to be cognizant of the fact that it may not, that it has to read all of the data in before it can start putting any of the data out, if that makes sense. But that's not too much of a problem in this case, because hopefully we'll be dealing with relatively short lists. So we also want to store all of the URLs that we've seen. Because of that, we're going to make that. I really feel like I should have done a make on that too. Yeah, that feels right. So, do you know what? We've already parsed the URLs, so let's actually store them as parsed instead. So this parse function returns a, I think it's a URL.URL, or pointer to a URL.URL, like that. And then after we parsed it, we'll say URLs is going to be append URLs like that. And that means that later we can loop over them again. And for each one, we're going to make a empty URL values. That needs to be an address, not a pointer. That's the wrong syntax, Tom. Main line 37, and that's supposed to be a range. I highly recommend having a go at programming things from scratch on a stream, by the way. It's a really good test of how bad you are at typing. So then we'll say, yeah, Copilot's on the ball today. For each of the parameters that we've seen for that hostname, we will say, we'll add the key, and we'll do a new string. We'll do the UID thing automatically here. Why not? I'm not the biggest fan of that, but it doesn't really matter so much, I don't think. And then, once we've done that, we will set the raw query and print out the URL. There we go. Okay, so let's see how we did. We need to initialize our Go module and tidy it to fetch that package. Oops. Input. Okay, so our input is our list of URLs, and our output is URLs that contain every possible parameter. Now, in this case, we had one with the same path twice, and I think a good optimization would be to deduplicate those, but for now we're going to kind of ignore that problem. So let's just hop back into our reflector tool and install it just so it's in our path. Now, we did that go run main input.go. So as a reminder, our state was we had this reflector program, which is looking for input that's been reflected in a page, and it was not finding something because the parameter that was vulnerable in this case was not on the vulnerable path. It was on a different path, and we wanted to try and solve that problem. So we're going to take the output of this tool and input it into this one, and hopefully and thankfully we now have again found this thing that we found previously, but without this search parameter having to exist on that URL. And this is kind of a toy example, but you know, and in that, like, cross-site scripting is pretty much is kind of done to death, right? But you can swap that out for other vulnerabilities, things like or local file disclosure or SQL injection or something perhaps very specific to a target that you're looking at, and combine it with other tools that give you a source of input. So in this case, you know, the input to this tool that does the handles the permutations of all the query string parameters. The input to that might be get all URLs or something like that, or it might be a list that you've copied out of Burp Suite, or it could come from anywhere. But that's really the important part here, is that to solve one problem we've written two tools, but they each themselves stand alone in a useful way. So we could feed URLs from a different source straight into the reflector tool, and vice versa. We could use the output of that parameter, the parameter permutator. I just came up with that. I called it allparams, but I think parameter permutator is a much better name for it. Can be an input to others, and that's really the message that I want to get across, is that writing these small, they're almost like functions, right? Really, that can talk to each other through some universal medium, whether that's plain text on standard in, standard out, or whether it's JSON on standard in, standard out. If your data you're dealing with is a little bit more complex, that bit is really important. But also, it doesn't take very long. You know, there's that XKCD comic about how long things might take to automate, and how like the automation takes over and all that kind of thing. That doesn't have to be true. So it's, you know, we finished writing tools at 1945. We started at, I think it was 1925 ish. Maybe someone correct me, but you know, it's like 10 minutes per tool whilst commentating them and so on and so forth. And yeah, I had a pretty good idea of what I was going to do before, but the the point is, I think people overestimate how long it takes to write these things, and maybe underestimate how useful they can become. So that's, I think, about everything that I had planned to talk to you about. But I'm very happy to answer any questions that you might have, or even criticisms or compliments if you're feeling particularly generous. But if not, thank you for listening to me waffle on about tools that I love so very dearly. So I'm in the Discord chat. I don't think there's any questions. We've got a thanks from Lantern. Thank you. It's very kind. It's been a little while since I've done anything like this, so I'm perhaps a little bit out of practice, but thankfully the code worked, which is always nice. Well, thanks. Do we have any questions coming in from the website, Sean? Is that something that can happen? Ooh, here's a question. Is it possible to be a successful engineer without ever building your own tools, relying solely on existing tools instead? Ooh, possible, maybe. I think that, like many of these things, the this is always the cry of the senior engineer, is it depends, and what it depends on in this case is what you mean by successful, but also what you mean by engineer. I think I would almost go so far as to say that the ability to build tools, at least for me, is one of the defining characteristics of an engineer. And I don't mean that in the case of software engineers specifically, but all kinds of engineer. So one of my, I was going to say guilty pleasures, but I'm not very guilty about it, to be honest. One of my great pleasures in life is watching mechanical engineers and machinists and things on YouTube. And it is very interesting to me how much making tools is just part of a project. Some will call it a side project or a tangent, or one of the terms we have in software engineering is yak shaving, where you go off on a quest to build something else to help you with your primary quest. But really, I think it's just the way that you build or do anything of consequence, really, is by making these things. And I want to add that, I wrote stuff in Go, but that the slide about what was it, how make tools, is that like shell scripting and that kind of thing, that counts as building tools. Really, it's about shaping your environment to better suit your needs. It's what the crow's thinking about, right? As the food is in the gap, and I need to get in there. They shape their environment. That's something that makes us intelligent, I hope, at least. As for whether you can be successful as a software engineer or something, or a security engineer, probably. There'll be a bunch of people who have made their living never straying into making their own things, and that's fine. But it's not me. It's not something that I can relate to. Cool. So we have another question. How do I creating your own tool versus contributing towards or using someone else's? When do you decide to reinvent the wheel? Again, the swan song of the senior engineer. It depends. but what does it depend on? Again, there's the obvious cases, right? As like nothing exists already, but there are the much less obvious cases where something seems to exist, uh, but maybe doesn't do exactly what you want. So you need to make modifications to it. And in that case, in the open source world, you may find that forking a piece of software and changing it that is the simplest solution. Um, it's making a trade-off between getting exactly what you want versus but taking longer versus not getting maybe exactly what you want and getting most of the way there and it taking less time. One of the interesting things that I think is perhaps not always evident is that sometimes writing your own tool is faster than contributing to somebody else's tool. I can't remember who said it, but there's a famous quote from some author or something that's along the lines of, I didn't have time to write a shorter letter. Uh, and that's and what they were getting at was it's easier to use more words than it is to use fewer. And I think there's kind of a similar thing with um, software where it feels contradictory that if a tool that nearly does what you want exists and you just need to change it a little bit, that seems like it should be easier than writing from scratch. But in reality, oftentimes that's not the case. And for a couple of reasons, one of which is you need to take the time to understand what exists already, and that's actually really difficult to do. I think reading code is a skill that fewer people have honed than writing code. Um, but also sometimes when people's intentions are only slightly misaligned, it can be very hard to get a correct course correction on them. So it might be that an existing project has a whole framework in place that makes doing what the author intended very easy. And if you want to do something slightly different, it might be very difficult. So that's something that you tend to take into account. Along with a whole host of other things, it's a very it's a big question, but it's a good one. Thank you. Another question: what would you say our most overlooked tools are? Tools that you use often, but others don't know enough about, or maybe a shout out to other indie tools you like. Indie tools. Oh, I think a very well-known tool, but I will always shout FFUF. Of the URL fuzzers. It's running Go, so that's always, always nice. It's fantastic, even though it prints an ASCII banner by default, which I'm not a fan of. I think ASCII art is cool, but I think it belongs on your README, not in my terminal. So FFUF. As far as my tools are concerned, I think it's a very well-known tool, but a new is one of the ones that really sort of still surprises me how useful it is. So a new is a tool for adding lines to text files, but skipping duplicates. And that's such a simple task to want to do that I was amazed at how annoying it was in the shell. So I just wrote this little tool that says, if I've got these things 0, 1, and 2, and I've got new things potentially 1, 2, 3, and 4, and I want to add these things to those things. Without this tool, I have to output them and sort them and unique them and pipe them into a new file, But then I've lost the ordering, and the order might matter to me. I might want to have things be always in the order that they were added, for example, and that's, as it turns out to be, a really annoying problem. It matched this um, process, wherever I put it, this process very well. I had this problem of I had a text file that contained domain names, I think it was probably, that I was piping into some other tools, and I wanted to add more stuff to the end. So I think a new is probably still underappreciated. Doesn't oh, it's got quite a few stars. Oh, that's the fork. I was looking at the fork count, thinking it was the star count. Maybe it's not that unknown as it used to be. Um, but yeah. Region Solar Grown. And that, I guess Gron's the other one I'll shout out, actually, because so this is pretty well known. It's in the default Ubuntu repositories, but I think maybe that some security people don't know about it so much. It's a very simple tool. The idea is it takes JSON and it turns it into statements like this, so you can grep them. And I wrote it because I was dealing with an API that was returning huge blobs of JSON, and there was no documentation. I had no idea where stuff was. I wanted to know the path to it. So, like, if you grep for a date in JSON, you just get this line, right, with no context. So that was the idea. So I'll leave it at that. Thanks, Tom. Your Gabriel was very useful. Thank you. Very welcome. Someone who uses a new and for weekly. That's also very good to hear. Well, I think we're about out of time. So thank you all very much for listening to me. And I hope at the very least you learn at least one thing. That is my hope. And maybe you even learned two. So that's it from me.
All right. Thanks for stopping by. We posted a quick little survey in the chat in Discord. If you have a second, fill that out. That's useful information for us so we know what to program for you. But thank you so much, Tom. That was awesome. I appreciate you putting in the time across the pond. I know it's late there for you, so I think you can clock out now, finally.
Super. Well,
thanks.
Have a good afternoon or evening or whatever time it is where you are, everybody. Bye.